Okay, so we're going to set up but not evaluate using cylindrical shells an integral for the volume of the solid obtained by rotating the region bounded by x squared minus y squared equals 7, x equals 4, and about y equals to 5. Okay, so let me draw my axis here. Now, if you don't quite recognize x squared minus y squared equals to 7, that's a hyperbola, but that's okay if you don't remember that. You can simply solve for y. So if you solve for y, notice that you get 7 minus, or sorry, the square root of x squared minus 7, but you get the, this is important, plus the positive and the negative one. Okay, so if you do that, you'll notice somewhere around here at square root of 7, you have a function that kind of looks like this and then like that. Okay, and then we have x equals to 4, which is just a vertical line, and I'm going to rotate this guy by y equals to 5. So let me put that down here. So let's say 5 is, let's go a little lower. Okay, so let's say this is 5. And so we're going to be rotating this guy. So let me draw the mirror image here. So I'm going to have something that looks like that. Okay, now I'm going to use the method of cylindrical shells. So let me just draw a shell in here. So basically, let me draw it here. Alright, so this, I'm assuming this is a cylindrical shell. And so it's not very detailed, but that's okay. Now the basics are that you're going to go to find the volume using cylindrical shells. You take the integral from 0 to the outside edge, which I'm just going to call b, and then it's 2 pi times the radius of the shell times the height of the shell. Now, in this case, notice that the shell is lying down, so the radius and the height are functions of y. So I'm going to integrate in this case with respect to y. Okay, so now I need to try to figure out what's the radius of this shell. So from here to here, for example, what's the function that describes that radius? Okay. And then another thing to keep in mind as well is that I'm going to have to subtract the, this is the shell that's on the outside, but then I'm going to have to subtract the shell that's formed by the inside. So see right here, you've got another shell. So to get the volume of the region enclosed, then you're going to have to subtract the outside minus the inside. Okay, so let's work on the outside one first. Okay, so I'm trying to find the length of this green line here, an expression for it. So notice that this green line is at whatever y is. So here, for example, if I'm at this point, the distance from here to here is y, and the whole thing is 5. So that means that my radius is going to be 5 minus y, because I'm looking for the distance from here to here. So from here to here. So the whole thing is 5. Take away y, you get 5 minus y. Now in this case, for this big blue one, the height of this cylinder, notice that it's always going to equal to 4 because the height is constant. Okay. Now then we're going to subtract this green shell. Now this green shell, so I'm going to do the integral again from 0 to b. We'll talk about what b is in a minute. But of 2 pi times the radius is going to be exactly the same, 5 minus y. But now the height of this guy is equal to now this purple line, which is going to be the x value, right? Because from here to here is the distance from here to here is x. And so we have to solve for x here. So if you grab the original one and you solve for x, you get that x is equal to the square root of y squared plus 7. So this is times the height, which is going to be the square root of y squared plus 7 dy. And now let's put in our b here. Let me erase these guys. Okay, so remember, these guys represent what y is going to go from and to. Now actually let me erase the bottom one here, because normally it's by 0, but here, because we're off center a little bit, it's going to actually be different. So just remember that this guy is from the center to the outer edge. Now if you take a look at these guys, notice that the first shell is going to be located right here at this value, and then the last shell is going to be located right here at the last value. So basically where they intersect. But notice that you're not going to go from the very bottom to the very top, because remember that each shell collects the volume from both ends, and so you only need to go from this point right here, which is where these two intersect, which we'll find in a minute. Let's do that over here. So we want to know, when does now we're talking about the y values, so we want to know, when does the square root of y squared so we want to know when does x squared minus y squared equal to 7. When does this guy, when x is equal to 4, what does y equal to? So, well, that's easy. We get 16 minus y squared equals to 7. So then we get that y is equal to plus or minus 3. And so these are the intersection points. And so then my interval is going to go from 3 to -3, and 3 to -3. So that's the outside minus the inside. And that's it. From -3 to 3, -3 to 3. And so if you, let me just put this together. This should equal to the integral, 2 pi times the integral from -3 to 3 of 5 minus y times, if I factor that 5 minus y out, 4 minus the square root of y squared plus 7 with respect to y. So that's good. And then if you approximate that, you should get about 163.027. And that's it.